Welcome back to Arts Learning. In this video, we'll be going over single inclines and more problems associated with it, as well as the more complex versions of the ramps we learned last time. So we'll be basing it directly off of that. So make sure you're good with those. Okay? This is just a revision of formulas you should know from the last video. For a frictionless incline, A is just equal to g sine theta, and normal force is mg cosine theta. When you're sliding down with friction, opposite direction, gravity and friction. When you're pushing up the slope, same direction, gravity and friction. Okay, so now let's look at a different type of problem which we haven't learned how to approach yet. A 15 kg block is on a 30 degree incline, tied over a top pulley to a 10 kg block on a flat top surface. So the angle here is 30 degrees. Is tied over a top pulley to 10 kgs over here. Okay? We're going to draw free body diagrams for both of those if you want to find the acceleration. Same step we've used for Atwood machines and all this sort, right? Same step. Here, since there's no friction, it's just tension to the right. Here, since there's a bunch of forces, mg here first of all, straight downward, right? mg cosine theta, which will match the normal force, and they'll just cancel out. Then we have mg sine theta, which will accelerate downward. But mg sine theta will be opposed by the force of tension because it's being pulled on by this block here, by this rope here. Okay? So the net force equation for this would be 10 kGa, because that's mass times acceleration, is equal to just tension, because that's the net force here. Okay? And for this one, it would be tension. And I'll say tension is positive because it's pulling upward. I'll say mg sine theta is negative because it's going downward, is equal to the net force, which is ma. But I have to put a negative here, okay? Be very careful. Because if I define this as the negative direction, and if gravity is pulling this way, and the block is going to accelerate downward, that means this has to be negative acceleration as well, right? So then I can substitute this into this. 10 kGa minus mg sine theta. So for here, before we substitute, we need to make sure what our m is, right? This time it's 15 for this block. So 15 kgs. Here also 15 kgs. So minus 15 times 9.8 sine of 30 is equal to negative 15 a, kgs a. So 10 kga, and then let's see what this mess adds up to. Minus 15 times 9.8 times sine of 30. Okay, that's negative 73.5. Is equal to negative 15 kgs times a. So if I add these to both sides to get all the accelerations on one side, 25 kgs acceleration times acceleration is equal to 73.5 newtons. I just sent this to the other side. A is equal to 73.5 divided by 25, or 2.94 meter per second squared. Okay? So yeah, that's pretty much it. Alright? And then, if you just wanted to find the tension, you just plug this back into this equation, right? 10 kg times 2.94 meter per second squared will give you your tension here. So it become 29.4 newtons. Or you could plug into the other equation, but that would be a bit more. Alright, so now let's try the same problem, but this time with friction. So let's draw the free body diagrams again. Okay? So before I do anything, I need to okay. I'm just going to draw the same problem here. 30 degrees, right? In the ramp, the 15 kg, and on the floor, the 10 kg. But now we have a coefficient of friction of mu k is equal to 0.1. So how am I going to solve this? Okay, so first I'm going to look at this block. I'm going to create the equation for this one using the free body diagram, okay? So you can see over here, tension is pulling to the right. I'm going to say right is positive. I'm going to say left is negative, okay? So force kinetic is opposing me. So tension is going to subtract force kinetic, which is just going to be mu k times the normal force, right? Which is mg, because this is on the floor. So it doesn't need a cosine theta, it's just going to be upward. So tension minus 0.1 times m, which is 10, times g, which is 9.8, right? So this should just be tension minus 9.8 newtons is equal to net force, or r m times a, right? So 10 kg times a. That's one of my equations. But now I need the other one, okay? So that's going to look like this. The other one is for the 15 kg block. So like I said, mg cosine theta and force normal cancel out, right? Those cancel out. We're left with mg sine theta, bringing my block downward. We're left with tension, making, so let me just say downward is negative, then that means mg sine theta is negative, right? And tension is pulling it upward from the rope. And then, but we have friction. What direction is friction? Opposing motion. So it's going to be in the same direction as tension, right? So it's going to be adding mu k mg cosine theta to my friction. And all of that is equal to negative 15 kg a. And it's going to be negative because acceleration is going to be downward, right? And since I defined mg sine theta, which is downward, as negative, this should also be negative. So tension minus, what is mg sine theta? 15 times 9.8 times sine of 30, right? Which is going to be 73.5. And then what else are we subtracting? Well, now we're not subtracting, we're adding, right? What are we adding? 0.1 mu k times mg cosine theta, right? Which is, m is here is 15 kg times 9.8 times cosine of 30. So 15 times 0.1 times 9.8 times cosine of 30. Okay. So then whatever answer I get, which is 12.73, I subtract 73.5 from it, right? It's also going to be equal to negative 15 kg times a. So this is going to end up t minus 60.77 approximately is equal to negative 15 kg a. Okay, yeah. And then I can get my other equation here, t minus 9.8 newtons is equal to 10 kg a. And then I can subtract both of them to cancel out the t's. T's cancel out. Negative 60.77 minus negative 9.8. So 9.8 minus 60.77 newtons, and newtons all around, is equal to negative 15 kga minus 10 kga, which is negative 25 kga. And 9.8 minus 60.77 is equal to negative 50.97, right? And that's equal to negative 25 kga. And then if you divide by negative 25 on both sides, you should get acceleration is equal to negative 50 divided by negative 25, approximately 2.04 meter per second squared. Okay, and I can just substitute this into this equation, and then T is equal to 10 kg times negative 2.04, or I mean it's positive, right? Because whoops, it's positive because these two negatives cancel out. So 10 times 2.04. Okay, that plus 9.8 is just 30.2 newtons. So 10 times the acceleration, 2.04, plus 9.8 is equal to tension, which is just 30.2 newtons. And there you go. That's how you do it. That's how you do these kind of problems, okay? And later, when I push out the PDF video, I'll show you how to do more complex versions that can have more kinematics based or integrated that into these free body diagrams. But overall, the one thing you want to keep in mind is you want to make sure you don't miss anything, okay? Look how many terms I have, look how many numbers I had. You always want to make sure you're clean and neat when you're writing this. Clear, clean, and neat, okay? And you want to make sure you have every variable accounted for. Otherwise, things can, even if you mess up one single number, your entire answer could go wrong because there's so many steps.